Acids and bases can be found all around us in our everyday products, including those we eat, we wear, and we use. Though they are commonly found, it is important to remember that they can be dangerous chemicals. Here are the examples of acids and bases that can be found around the house. These include sodium bicarbonate, sodium hydroxide, and boric acid. The pH scale is very important in context of acids and bases. It ranges from 0 to 14. If a substance is acidic, it has a pH of less than 7. If a substance is alkaline or basic, its pH is greater than 7, and if a substance is neutral, it has a pH of exactly 7. The first acid, boric acid, has a pH of 3.8. It is commonly used in care products, nutritional supplements, glass industry, and in fungal and pest control. In pharmaceuticals and cosmetics, boric acid is used in a wide range of personal care products because it acts as a mild antiseptic that inhibits bacterial growth on external surfaces. This protects products from spoilage. Its antiseptic properties allows it to be used in contact lens solutions to kill any microorganisms present. Boric acid also maintains an emulsion, which is a mixture of normally immiscible liquids such as oil and water, and such emulsions are commonly found in makeup. Furthermore, boric acid is used in pest and fungal control because of its antibacterial and antifungal properties. Boron compounds inhibit the growth of fungus and have been demonstrated to be reliable wood preservatives. Boric acid is not highly toxic. In fact, it's often found in nature. Rather, it acts as a desiccant that dehydrates many insects by causing tiny cracks or fissures in their exoskeletons. This eventually dries them out. Boric acid also interferes with a very simple electrolytic metabolism. Interestingly, silly putty, a common toy, was originally invented as a substitute for rubber. It's a mixture of silicone oil and boric acid. The base, sodium hydroxide, is a very strong base with a pH of 14. It's also known as caustic soda or lye. It is made by the electrolysis of a solution of sodium chloride and water to form sodium hydroxide, chlorine gas, and hydrogen gas, and this is called the chloralkali process. Sodium hydroxide is used in petroleum refining to neutralize and remove acids, in the paper industry, and in a variety of cleaning products that include drain cleaners, oven cleaners, and detergents. Drain cleaners and oven cleaners contain sodium hydroxide that removes oils and fats that build up on surfaces by converting them to soap, which is soluble in water. This process is called saponification, in which when sodium hydroxide is added to fats, glycerol separates out and leaves behind sodium oleate, a crude soap. This is an exothermic reaction, and the heat release helps melt clogs and drains and makes it easier to clean. For these reasons, sodium hydroxide is also used in soaps. Bases are also used as antacids to relieve symptoms of heartburn and indigestion caused by the oversecretion of acidic gastric juices. Sodium bicarbonate, calcium carbonate, and magnesium hydroxide are all used as antacids. Sodium bicarbonate in particular has a pH of 8.3 and is used as an antacid and as leavening agents in baking soda and baking powder. At 100 degrees Celsius, sodium bicarbonate begins to break down into carbon dioxide, water, and sodium carbonate, and for this reason it's used in baking. This release of carbon dioxide gas expands the mixture, giving it a light, fluffy, desired texture. Sodium bicarbonate reacts with the hydrochloric acid in the stomach in a neutralizing reaction to produce carbonic acid that breaks down into water and carbon dioxide gas, thus neutralizing the chyme in our stomach. There are many benefits associated with acids and bases. They are commonly used in the field of medicine and pharmacy, giving us many health benefits. Many of the drugs we use are weak acids or bases as shown in the chart. For example, salicylic acid can be found in the common drug aspirin. The reaction of acids and bases with each other or with other substances produces materials essential to everyday life and the economy. So for example, sulfuric acid is used in the manufacturing of paint, fertilizers, and textiles. Some acids and bases can provide more economical and environmentally friendly solutions to our problems. So for example, because boric acid is found naturally, it is more environmentally friendly compared to other toxic pesticides. With the benefits, there are also many risks. For one, acids and bases can pose as safety hazards because of their corrosive nature. Contact with skin or eyes can cause severe burns, and more widespread use of acids and bases in the household increases the chance of accidents and exposure to substances such as sodium hydroxide or even sulfuric acid through battery leakages. Increasing demand for acids and bases in everyday products increases the manufacturing of acids and bases, which releases pollutants into the environment. So for example, mercury is used to produce sodium hydroxide, but some of this mercury can also escape into the environment. As acids and bases become more prevalent in our everyday life, the chances of improper disposal also increases. In fact, many strong acids and bases are classified as hazardous waste. These pose dangers to humans and wildlife. So, for example, sodium hydroxide can decompose easily to form sodium oxide, a hazardous gas. Battery acid containing sulfuric acid can also leak from batteries. As you have learned, acids and bases aren't just prominent in the area of chemistry. It is important to specialists in medicine and ecology, and they can be found all around us in society. Many Canadian initiatives can be found in medicine. A recent study at the University of Alberta in 2007 showed results that sodium dichloroacetate, or DCA, a buffer form of dichloroacetic acid, could shrink tumor cells. Results from the first clinical trial in 2010, however, showed no conclusions could be made, and research is still ongoing. Folic acid was also shown to decrease birth defects during pregnancy. In 2007, Mother Risk Program and the Society of Obstetricians and Gynecologists of Canada updated the clinical guidelines for folic acid to increase folic acid supplements. In 2009, Health Canada released prenatal nutrition guidelines that endorse the use of folic acid supplements. Thank you so much for listening. I hope you enjoyed my presentation.